So the parts of those things that we just solved that we're going to need are going to be our r prime of t, which is going to be negative sine t. We solved this earlier. Cosine t, negative tangent of t. And we're also going to need our b of t, which is the big long one that we did, which equals, try to write really small, negative cosine cubed t minus sine t sine 2t over the square root of cosine squared t plus 1, and then cosine 2t sine t minus cosine squared t sine t. Sorry, my dog's moving around a little bit. Square root of cosine squared t plus 1. And then the last component is going to be, of course, really long, even though I'm running out of space. Cosine t sine 2t plus cosine squared t cosine 2t over cosine squared t plus 1 square rooted. Alright, so you guys might not be able to read that well, but I guess I'm sorry. So now what we need to do is decide where we're going to evaluate t from. So if we go back to the work that we just did, we'll notice that our point that we were given is, where did I write that? I didn't write the point. Well, anyway, the point that we were given in our problem here is 1, 0, 0. And we'll notice that cosine of t is 1, sine of t is 0, evaluated at this point obviously, and then the ln of cosine of t is 0 as well. So we know that cosine of 0 is 1, we know that sine of t is 1, and since cosine of t is 1, that means that the ln of cosine of t is 0. So we're going to evaluate at t equals 0. So going back to part, we now know that t equals 0, and our r prime of 0 is going to be pretty easy. Sine of 0 is 0, cosine of 0 is 1, and negative tangent of 0 is 0. So now this is going to be A, this is going to be B, and then this is going to be C. And we're going to plug that back into our formula, and then this is going to be our point, which was 1, 1, 0, 0. Is going to be x1, y1, z1. So we're going to get 0. This is going to be our normal plane, by the way. Normal plane. It's going to be 0 times x minus 1 plus 1 times y minus 0 plus 0 times z minus 0 equals 0. So obviously this is going to go away and this is going to go away, and the plane that we're going to get is y is equal to 0. And that is the first part. Now the next part that we're going to do is find the oscillating plane, or osculating, I'm actually not sure how to say that, osculating plane. And that is going to be our b of t evaluated at 0. So we know that b of 0, if we work this out, so the cosine of 0 is going to be 1. So if we cube it, it's still going to be 1, and then negative 1. So we know that this is going to be negative 1 minus 0 divided by cosine of 0 is 1. All of these are going to be cosine of 0 plus 1 square root, which is just going to be the square root of 2. So it's basically going to be negative 1 over the square root of 2. If we multiply by 1, so square root of 2 over square root of 2, we're going to get square root of 2 over 2, just so that we don't have a square root on the bottom. It's bad etiquette. 2 over 2 for our x component, or rather negative. And then next up, cosine, it's multiplied by a sine of 0, so this is 0. Multiplied by a sine of 0, so this is 0. So it doesn't matter what's on the bottom because we know that it's square root of 2, so this component is going to be 0. As long as we're not dividing by 0, it doesn't really matter what's on the bottom. And then cosine times sine of 0, so our sine, so 0. And then cosine squared of 0, which is going to be 1, times 1. So this is going to be 1 over square root of 2, which is just going to be square root of 2 over 2. And then we're going to do this the same exact way that we just did this one. So we know that this is going to be A, B, C. So our oscillating plane formula is going to be negative square root of 2 over 2 times x minus 1 plus 0 times y minus 1 plus square root of 2 over 2. Hey, get that out. Sorry, my dog's eating a chair. Square root of 2 over 2 times z minus 0 is equal to 0. So we're just going to multiply this through. So negative square root of 2 times x minus 1 all over 2. Y goes away. Plus square root of 2 times z, I'll put it a little bit away so it doesn't look like it's under the radical, over 2 is equal to 0. And this is going to be the equation for our oscillating plane.